Alright, so let's get started with creating our project. So I'm going to start by creating a new empty project here inside of Defold. I'm going to call this one block breaker, and then we can click create. Alright, so now inside of Defold, what we're going to do is just set up our folders. So we're going to start by creating two main folders. Okay, our first one is going to be called assets. So I'm going to right click on my block breaker folder, go new folder. I'm going to call this assets, and this is where we're going to be storing all of the files like audio and images for our sprites. Now if you downloaded the course files, which should be on the course files tab containing the assets, you should have a file that you can then extract, which contains a sounds and a sprites folder. Sounds contains two different sound effects for ball hit and block break, as well as a number of different sprites sourced from kenny.nl, which we are going to use for our game. Now I'm simply going to select these two folders and drag them into our assets here. So now they have been successfully imported. Okay, and the other folder we are going to create is going to be called game, and this is where we're going to store all of our game related assets such as scripts, collections, and game objects. Now something else we want to do is go ahead and set up our sprites, because by default we can't use, for example, our ball gray.png as a sprite, because a PNG is not technically a sprite, it is just an image file. So we are going to create something known as a sprite atlas, and a sprite atlas is essentially a file which contains a number of different images that we can define as sprites. So if I go ahead and right click on the sprites folder, go new, and then go down to where we have, or at the top to where we have Atlas. I'm going to call this one Sprites. And inside of the Sprite Atlas, you'll see we have basically this blank screen. And simply what we're going to do is select all of the different PNGs we have imported and drag them in. Now what you'll see is it essentially creates one large image with all of these stacked up against each other here. And we can then basically select these individual sprites whenever we want to use them on a sprite component. Okay, so we can save that. And we'll get into actually setting up the sprites once we create our paddle, our background, etc. But what we're going to do now is set up our main game collection. So I'm going to go to the game folder, right click on that, go new, and then we'll go down to where we have collection, and I'm going to call this game. This is where our game is going to run. This is where we're going to have the ball, the paddle, the blocks, the camera, the background, everything. Now, in order for this game collection to run at the start of the game, we have to go ahead to our game.project file, open that up, and then over in the Bootstrap tab here, we want to change the main collection from the default main collection to our game collection here. So now when we run the game with F5, that is going to launch our game scene, which of course we have nothing inside of it, so we need to give it a background. Now, to create a background, what we're going to do is inside of our game collection, let's go ahead and create a brand new game object. I'm going to change the name of this to be map, and as a child of that, we're then going to create a component, and that component is going to be a sprite. I'm going to rename this to be our background sprite, and then we want this to essentially be that big background texture that we have right here. So to do that, with our background sprite, we're going to go down, set the image to be that sprite atlas, and then set the default animation to be background. Now, as you can see, it is going to set that to be the correct sprite. If I go ahead and run this, you'll see that it looks a bit funny. And the reason why is because by default, if we have no camera in the scene, our game is going to render from the 0, 0 coordinate and then outwards up and to the right. Okay, so what we need to do is create a camera that is centered on our scene here. So to do that, I am going to create a brand new game object, call this one camera, and we are then going to attach a camera component to that, just like that. Now our camera is going to be working in 2D, so we want to enable orthographic projection. Essentially, we want to render our collection without any depth. Okay, we aren't rendering objects in the distance, we're just rendering 2D. So I'm going to enable orthographic projection right here. And if I go ahead and run this, you'll see that something weird happens, and that is we don't actually see anything on screen. Now, the reason why is because if we go down to our camera's near Z, which is the, basically, if anything is within 0.1 meters of our camera's render distance, it is not going to render that. The near Z is really only useful for 3D games to prevent clipping right up close to the camera, so we are going to set this to 0 because our camera and our sprite are on the exact same Z depth. Now, if I save that and run, you should see we have the background right here. And I did make sure that this background is actually the exact same size as the default render resolution, so no need to modify that here. But of course, if you want a more, for example, vertical, for example, if you're creating a game for a mobile, then you can of course modify the background or create your own for that. We have our background, we have our camera rendering, we have our sprite setup. Now in the next lesson, I think we should get into actually creating something tactile, and that is going to be our paddle. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be working on our paddle, which is going to be essentially the player, you could think of it, okay? We're going to be able to move the paddle around by basically moving our mouse across the screen. The paddle is going to track to our mouse's X position, and the ball is then going to be able to bounce off it, hit the blocks, and yeah, that is how we are going to play the game. So for our paddle, we are going to create a brand new game object here in our collection. This one is going to be called paddle, and we then want to attach a couple different components to this. First of all, we need a sprite to actually render our paddle, so we're going to create a sprite component. This, we are going to set the image to be our sprite's atlas, set the animation to then be paddle blue or paddle red, that's up to you. Now, you may notice that we can't actually see the paddle sprite. You might be able to on your screen, but for me, we cannot. And the reason why is because the paddle sprite and the background are on the same Z depth, okay? Meaning that they're kind of fighting to be on top. So what we need to do is make it so that our background is going to be sort of pushed backwards, okay, into the distance. And for this, I'm going to open up our map object, select our background sprite, and set its Z position to be something such as -100, okay? So we're sort of pushing our background further in the distance so that it'll never overlap anything else ever again. Now, back to our paddle, we can see that we now have it on screen. I'm then going to move it down to about where we want it. I'd say probably about there. Now we need to add a collider to our paddle, so when the ball hits it, we actually know what we are hitting. So I'm going to create a brand new collision object component. And on this collision object component, we want to make sure that its type is kinematic, meaning that we are going to control the paddle's movement in script. Now, also what we're going to do is go down to the bottom where we have our group and our mask. Now, a group and mask are useful and are used when trying to calculate collision events, okay? Because right now you can see both are set to default, meaning that every collider in our game is going to be default. And this is fine, you know, if the ball hits the paddle, which they're both default, it's going to trigger the collision and everything like that. But what we want to do is when the ball hits something, we want to know what we hit. Did we hit the paddle? Did we hit a wall? Did we hit a block? Because different things are going to happen when we hit different things, okay? So what we need to do is define this paddle as the group paddle, just like that. And you can add multiple groups to the same object. So for example, we go paddle, comma, and then movable or something like that. But we're just going to keep it as paddle. And then the mask we are going to set to be ball. Now, what is group and what is mask? Now, I said they work with the collision system, but how does that work? Well, essentially, the group is essentially the group that this collision object is assigned to. This is in the paddle group. And the mask basically defines the other groups that it can detect collisions with. So right now, I am basically saying that this paddle can only detect collisions with other objects that are in the ball group. Now, the reason why we do that is first of all, just to make things a bit simpler and know what we are interacting with, and also if you have a larger scale game, it's going to be much more performance friendly if you split your collisions up into these individual groups, as otherwise, our ball will be looking through every single collision object in our collection to see if it's colliding with it. Otherwise, for example, if we tell our ball, okay, you can only collide with A, it is only going to search for collisions with objects in the group A. And you can see if you have a much larger scaled up game, that is going to be more performance friendly. But for us, the main benefit is going to know exactly what we hit. Since the ball is going to hit the paddle, we can then check to see that paddle's group and know exactly what we hit, okay? So yeah. Now what we need to do is then attach a shape to this collision object. So I'm going to attach a shape box, and then we can go ahead and change its dimensions here. Something like this, I believe it's 104, and the height is going to be around 24. There we go. And then finally, the last component is going to be a script. So if we go over to our game folder, I'm going to right click, go new, go down to script, make sure it is just script, not render script, not GUI script, just a normal script, and call it paddle. Now, before we begin filling out the script, let's go back to our game collection and attach it to our paddle by right clicking on the game object, add component file, paddle script, okay, and there we go. So now any code we write inside of this paddle script will be basically run on our paddle. Alright, so in the next lesson, we are going to begin looking at scripting our paddle, essentially making it so that it'll track left and right based on our mouse position, and also have it so that the paddle will not go beyond, the leftmost position, which is about here, and it won't go above the rightmost position, which is here. So we're going to clamp the paddle within the screen bounds as well, okay? So thanks for watching, and I'll see you all then. Alright, so let's get started with our paddle script. So I'm going to go over to our paddle here, and we need to basically delete some functions because we're not going to need all of these. I'm going to start by deleting the comments inside of init because we are going to be using that. Final, we can delete. Update, we're going to keep. Fixed update and message, we can go ahead and delete. We're going to keep on input because we need to actually get our mouse position, and on reload we can delete as well. So these are the three functions we're going to have by default. Now, inside of the init function is where we are going to basically acquire input focus, meaning that we can then use the onInput function, which detects mouse, keyboard, controller, touch, inputs, etc. Because by default, the onInput function is not really going to do anything, and that is because we need to specifically tell the game object to listen for inputs. And to do this, we can simply go msg.post. The receiver is going to be our own game object, so a shorthand for that is by just having a single full stop, and the message ID is going to be acquire input focus, okay? Then we can go ahead and create our variables. For now, we are just going to have one, which is going to be called self.mouseXpos, and we'll just make that equal to 0 for now. This is going to be our mouse position on the screen along the x-axis, and we're going to set this down in the onInput function. So to set this, all we're going to do is simply go self.mouseXpos equals action.x. Now action is a parameter that gets sent over containing a bunch of the input data, and the x value that we are extracting from it is going to be our mouse's x position, okay? Its horizontal position. Now, over inside of update is then where we want to set our mouse's position, or set our paddle position, I mean. So we're going to start by getting our paddle position at this current frame. So we'll go local pos equals go.getPosition. Then what we're going to do is set our x position by going pos.x equals self.mouseXposition, and then finally set it again. So we'll go go.setPosition pos. So here what we're doing is essentially just setting our x position to be this mouse x pos. Now if I go ahead and run this, what you'll notice is that it's a bit strange. It might be a bit hard to see my mouse, but my mouse is currently on the left-hand side of the screen, and the paddle is at the center. If I move my mouse to the center, our paddle is sort of on the right-hand side. So what's going on here? Well, essentially what we need to do is we need to convert our mouse position from screen coordinates over into world coordinates, because when it comes to screen coordinates, 0, 0 is not in the center like it is with our collections, but rather at the bottom left of the screen, and it goes up vertically and it goes up to the right as well. So what we need to do is figure out a way of converting that. So we're going to start by going and getting our screen dimensions. So I'm going to create a local variable called screen_width and then comma screen height equals window.getSize. Now, something good about the Lua language is that a function can return multiple values, and if we do something like this where we have a variable comma variable, it is going to return the width into the first variable and the height into the second variable. So this is just a great way of getting our width and our height in a single line. Then what we need to do is get the center of our screen. Okay, what screen position, what screen coordinate is the center? So for this, I'm going to go local x center equals our screen width divided by 2. Screen width divided by 2. So now this is the x position in the middle of our screen. Okay, so now down here where we are setting our position, instead of setting it directly, what we're then going to do is subtract our screen x center. Now if I go ahead and press play, you'll see that our paddle is now moving nicely, okay? But I'm not too sure how it's going to come across in the video, but if you are following along, you may notice that the paddle, it does track well to our mouse, but it doesn't feel that nice. It feels pretty jittery, and that is because it is snapping directly to our mouse position each frame. What's going to both look and feel nicer is to actually have a little bit of a delay and have some smoothness to our mouse position change. Now to do that, we're going to use what is known as linear interpolation, okay? Basically moving from one number to another at a certain delta. So what I'm going to do is, instead of directly setting our x position, we are going to go pos.x equals vmath.lerp. We now give it a t, which is basically the interpolation value. I am going to simply enter in dt for delta time, which is going to make this consistent along frame rates, and then multiply it by 15. We can of course adjust this number later on, but we're going to keep it like that for now. N1 is where we are moving from, so pos.x, and N2 is our target position. So this is going to be our self.mousex position minus the screen x center. Now, if I go ahead and run this, again, you might not notice it on the video, but if you are following along at home, or if you are actually testing the project out afterwards, you'll notice that this has a bit of a smoothness now applied, and our paddle actually has a bit of a delay between following the mouse position, which at first may seem a bit of a strange thing to add, but it just makes the whole thing feel a bit nicer and a bit more dynamic, I guess the word could be. Now, there's one more thing we need to do with our paddle, and that is make it so that when our mouse goes beyond our screen, our paddle does not go off. The reason why is because we want our paddle to always be on screen, so we want to basically stop it from going off screen from either side. And we can do this by clamping the X position. Now, to clamp the X position, we are essentially going, before we set it here, we are going to go if pos.x is greater than, and let's figure out what the extent on the right hand side is going to be. So if I get our paddle and move it as far to the right as it can go, so the collider is rubbing up against the edge, that is going to be an x position of 428. So here what I'm going to do is I'm going to go if position.x is greater than 428, then pos.x equals 428, okay? So now, if I go ahead and run this, what's happening is our paddle can no longer go beyond the X position of 428. Let's now go ahead and do it for the left-hand side, which is simply going to be else if pos.x is less than negative 428, because remember, the middle of our screen is going to be the 0 position. then pos.x equals minus 428, and then end that off right there. Now, if I go ahead and press play again, you'll see that our paddle now sticks to the screen always. So it's going to be easy to get the balls that sort of bounce right in the corner. We just need to swing our mouse as far to the right as possible, not needing to worry about it accidentally slipping off screen. Okay, so that is the code for our paddle right here. Now, in the next lesson, we are going to actually begin setting up some walls and boundaries before going ahead and setting up our ball, which can then bounce around. So thanks for watching, and I'll see you all then. Welcome back everyone. In this lesson, we are going to be creating our walls around our level, just so that when we add the ball in for the next lesson, we aren't going to worry about hitting the ball and then having it just fly away. Okay, so let's start with that. So inside of our map object, we are going to right click and go add component collision object. And this is going to be basically for the top, down, left, and right walls. Now later on, we are going to remove the bottom wall and create that as a sort of game over zone if the ball hits. But for now, we're just going to have everything a wall so that the ball can bounce around freely. So on the collision object, we want to go down to where we have our group and mask and change the group from default to wall and the mask to be ball. Meaning that the walls are going to be in the group called wall and the mask is essentially what groups they're going to be trying to detect collisions with. We don't need the wall to really collide with the paddle or the blocks, so we're only going to have it detect for the ball. Then we can add our collision shapes. So I'm going to right click on collision object, add shape, box. We can then go ahead and resize it. So for the dimensions, I'm going to bump this up to maybe 50 by 50 like so. Then we can drag this up here, make sure that it sits exactly snug against our level border because this is essentially our screen dimensions. And then we can crank up the width, okay, something like that. There we go. Now we can simply get our box, copy and paste with Control-C, Control-V, press E to go to the rotate tool, and then just go ahead and rotate that one around like so. We can actually go down into our rotation and set that to be -90 on the Z, so it's exact. And then move it over like so. Again, we don't really have to be exact or precise with our colliders in terms of their width and height because we only need to worry about the inside being fully sealed. Copy and paste that one again. Move it over to the other side, like that. And then finally, we can copy and paste the top one, and then bring it down to the bottom here. Okay, and there we go. So now we have our entire screen encapsulated with colliders, meaning that we're not going to worry about the ball just flying out. Now in the next lesson, we are going to begin creating our ball and the script to allow it to bounce around. So thanks for watching, and I'll see you all then. Alright, so let's get started on creating our ball. So like with everything else, this is going to be a game object. So we'll add game object. I'm going to call this one ball. Now our ball is going to of course need a sprite and a collider and a script. So let's start with the sprite. We'll add the sprite component, set its image to be that sprite atlas and its animation to be ball blue. So there we go, we got it on screen. Now we need a collider, so we're going to attach a collision object component to the ball. Now if we go down into the properties here, actually, first of all, one thing I forgot to do in the last lesson, for our map, we want to go to our collision object and change its type from dynamic to static, okay? Because otherwise, it's going to begin actually falling down, which we don't want. So changing it to static basically means it's not going to move. It's going to stay in place always. Now again, for our collision on our ball, what we're going to do is we're going to set it from not dynamic but to kinematic. Now you may be thinking, our ball is going to be, bouncing around, colliding and hitting things. Why don't we make it dynamic? Dynamic is going to allow it to actually hit and roll and bounce, but the reason why we're doing this is because we want to have full control over how fast it moves, how it bounces, and exactly the trajectory that it might bounce from when it hits an object, okay? Because it's going to be different when it hits a wall. For example, when it hits a wall, it is going to reflect, meaning that if it hits at one angle, that angle is going to be reflected based on the wall's facing direction. So it's going to bounce like this. Whereas if it hits the paddle, we might want the ball to, for example, if it hits the center, it might just do its typical bounce trajectory. But if it hits one of the edges, if you've played a breakout game before, it typically bounces in the direction closer to the edge. So if it hits the right edge, it's going to bounce to the right. If it's the left edge, it's going to bounce to the left, okay? And that is just going to allow us to have a bit more control over the ball as the player. So on our collision object, let's set the type to kinematic. And then if we go down to the group and mask, I'm going to set the group to be ball and the mask to be not one, but 3 different masks. It's going to be paddle, comma, wall, comma, block. Meaning we want the ball to be able to detect collisions with the paddle, the walls, and the blocks, which we'll be adding in later on. Okay, and that is because, of course, the ball is going to be the main interactive element of our game. And then finally, we of course need a shape for this collision object. So we'll go add shape, sphere, and we can then adjust that like so. And there we go. So that is our ball. Again, if we go ahead and press play, nothing is going to happen because our ball has no code yet. So let's go ahead and create a script for it. So in our games folder, let's go ahead and create a new script. This one is going to be for our ball. And then we can attach it by right-clicking on the ball game object, going add component file, ball.script. Okay. Now over in our ball.script, we are going to basically define and delete the functions that we need and don't need. So init, we're going to need this, so we'll keep this. Final, we do not need. Update, we need, so we'll just delete the comments. Fixed update, no. And on message, we do need, and the rest we can go ahead and just delete. Okay, so these are the 3 main functions we will be needing. Now there's also going to be another function that we want to create just above the onMessage function. I'm going to create it, and it will be called a local function handle collision. Okay, this is going to send over self as well as another parameter called col, which stands for collision. And this function is going to be called whenever the ball collides with something, okay? Whenever we collide with something, we're going to call this function, sending over the collision data. Now, in terms of variables, let's go up to the init function here and define those. So we're going to have 3 different variables for the ball. Okay, the first one is going to be our move direction. So move dir for direction equals vmath.vector3. This is essentially going to be the direction normalized to a length of 1 in which we want to move. So by default, we'll have the ball moving upwards. And for that, I'm going to go 0 on the X, 1 on the Y, 0 on the Z. So by default, our ball is going to move directly up. Our next variable is going to be its speed, so speed equals 300. Now this speed variable is going to change over time. Okay, at the start of the game, it's going to be moving at 300 pixels per second, but each time the ball hits the paddle, it's going to be increased by a certain amount, and each time it hits a block, it's going to be increased as well. So this makes it that the game is going to go faster and faster the more the player plays the game, which is going to increase in the challenge then. Along with this, we also want to have a max speed because we don't want the ball going too fast that it's almost impossible to play or too fast that it actually clips out of the collider. So we'll then go self.maxSpeed equals, and let's just say 1500, okay? Let's say 1500 is the maximum velocity that the ball can move at. Now, to move the ball, what we're going to do is then go to update, and we want to start by getting the ball's position. So local pos equals go.getPosition. Then we want to modify its position based on the move direction and speed. So to do this, we can go pos equals pos plus self.moveDirection multiplied by self.speed. Now this is going to make us move very fast, and the reason why is because we also need to multiply by the delta time that is being sent over as the parameter. Essentially dt or delta time is the time between frames. Okay, this is a very, very small number. So what we're doing here is shrinking the change in position down to a very, very small amount. Okay, probably only a couple pixels, but this makes it so that we move at 300 pixels per second no matter the frame rate. Otherwise, if we remove the delta time multiplication, then our movement will be tied to the frame rate, which we do not want, as other people are going to have different ball speeds then. So now finally we just set our ball's position again, so go.setPosition, pos, And that should be it. Now, if I go ahead and press play, you'll see that the ball flies off screen. It's a bit hard because the screen does take some time to adjust, but as you can see, when I start the game, the ball sort of just floats off up into the air. Now, we don't want that to happen. What we want to happen is for when the ball hits a collider, such as one of the walls that is around all four sides of our screen, we want the ball to essentially bounce. We want it to bounce back. And we then want it to bounce when it hits the paddle as well. So how can we do that? Well, we can do that by detecting a collision. Now, the collision is first of all going to be recognized as a message. So if we go down to on message, we can check to see if the message ID that is being sent is equal to hash, and the message is contact collision or contact point response. So contact point response, this is a message that gets sent by our ball's collision object when it has hit the collider of an object that its mask is defined as. So if it hits the paddle, a wall, or another block, that collision event will be triggered. And make sure that down here you have collision events enabled so that we can actually detect those, as well as contact events too. Now, back inside of the ball script, what we're then going to do is essentially call this handle collision, which is going to run the code to detect did we hit a paddle, a wall, a block, and if so, run the respective code. So here we are essentially going to call handle collision, sending over self, and the message. Now the message contains all of the data for this event or for this collision message, such as what object did we hit, what is the normal direction of the surface, what velocity, what distance did our ball sink into its collider, etc. So that is what this is for. Okay. So now that we have all that set up, we can move over to our handle collision function and begin writing our code. Now this is going to be the bulk of our ball's code, so we aren't going to write it all in the next lesson, but we are going to write a good chunk. And I'll see you all then. Welcome back everyone. In this lesson, we are going to continue with our ball script by looking at actually setting up the ability to collide with objects. Now, if I go ahead and run the game, you'll see how the ball is going to fly up and disappear. In fact, let me just go ahead and change the ball's speed to 200 and move it down a little bit just so we can see it a bit easier in action. Alright, so if I press play, you'll see our ball is going to move up and it goes beyond the top of the screen. Well, we don't want it to move up and beyond. We want it to essentially hit that barrier and stop moving. Now, to do that, what we need to do is over here inside of the handle collision function, which gets called when a contact point response has been triggered. Essentially, contact point response is when two colliders have sort of contacted each other, and that information gets sent over. Now what we're going to do in handle collision is first of all adjust the ball's distance. We need to fix the ball's position. Now what do I mean by this? Well, essentially when our ball is moving and it hits a surface, it is not going to be exactly touching it, okay? So the ball is not going to be like this, for example, okay, along the surface. Since we are working in frames, for example, one frame it'll be here, next frame it'll be here, then here, then here, then here. Okay, so you'll see that it's ever rarely is the ball going to automatically on one frame be touching it precisely where we want it to. Instead, the ball is probably going to be sunk into that collider a little bit. Now, what we need to do is essentially fix that position. We need to make it so that the ball is no longer sunk in the collider, but rather sitting directly above it. So we need to get something like this, okay? We need to convert it from something like this to this. And we do that with two different values. The normal of the surface we hit. Now, whenever I am saying normal, I am referring to the normal direction. Okay, you can think of it as if we have a table and you have an arrow essentially pointing up from that surface, okay? If it was a wall, the arrow would be pointing out sideways, a ceiling, it would be pointing down. And if you then had, for example, a slope, that arrow would be pointing at a bit of an angle. So the normal direction is essentially the direction that the facing object we hit is pointing in. For example, if the ball hits the ground, the normal direction is going to be pointing up. Now, when the ball hits an object, it is probably going to sink in a little bit just because of the frame-by-frame movement, and the amount that it is sunk into the object is known as the distance. So what we want to do is essentially get the distance and move it that amount along the normal direction, okay, in order to fix its position. So let's go ahead and do that. So here inside of handle collision, we are essentially going to get our ball's position by going local pos equals go.getPosition, and then we can set our position by going go.setPosition, and the position we're going to set is going to be pos plus that normal direction multiplied by the distance. So col, which we are accessing the message that we sent over, which contains all of the data such as the normal and the distance. So we'll go col.normal multiplied by col.distance. And if we go ahead and run this, you'll see that a ball is going to move up and it hits and it stops right there because it can no longer go any further. But we don't want the ball to just hit and stop. We of course want it to bounce. Now how do we do that? Well, to make the ball bounce, I'm just going to add a little comment here which says fix collided position. What we need to do is essentially something known as a vector reflection. Okay, and a vector reflection is, and I'll get up a little diagram here, a vector reflection is where we have an in direction. For example, this red arrow here is the direction that the ball might be moving. Then when it hits a surface, we want it to reflect that in angle and basically bounce out. So the out move direction is just going to be a reflection of the in direction based on the normal. Okay, remember the normal is the direction that the surface is pointing in. So we need to take both the in direction and the normal in order to calculate our out direction. Now this is going to be a bit of a complex looking formula, but at the end of the day, we're simply doing this. So how do we calculate that? Well, here at the top of our handle collision function, I'm going to create a new local variable called new move direction. This is going to take our current move direction. It's going to take the normal of the surface we hit and then output a new move direction, basically reflecting of that. So this is going to equal our current move direction, subtracting 2, multiplying vmath dot. Now the dot function, I'll get into that in just a second, but the dot function, we're going to give it two vectors. The first one is going to be our move direction, and the second one is going to be the normal of the surface we hit, and then we'll multiply everything by the normal direction. So this right here is the formula we use in order to calculate the reflected vector. So after we get the new move direction, we can then go, for example, self dot move direction equals new move direction. Now if I go ahead and press play, you'll see the ball's going to move up, and then when it hits the top, it's going to bounce back down. If it hits the paddle, it's going to do the exact same thing. So our ball is now bouncing off that reflected angle. Now to make it a bit more interesting, we can change the start move direction. So for example, I can set the X here to be 1 and the Y to be 1. Now if I press play, you'll see it's moving off in a 45-degree angle, and it bounces as you would expect it to bounce, okay, which is pretty cool. Now, I used a new function, the vmath dot function. So what is the dot function, or also known as the dot product? Well, this is a very handy function which returns to us a number ranging from 1 to -1. So let's have a look at how that works. So the dot product, essentially, it works like this. We give it two vectors, okay? If these two vectors are parallel to each other, essentially, if these two vectors are pointed in the same direction, it returns the number 1. If these two vectors are adjacent from one another, so basically if there's a 90-degree angle, it returns 0. If these two vectors are pointed away from each other, it returns -1. And it then returns a number from anywhere in between. So if the two vectors are sort of angled away from each other, it might return a value such as 0.7. So the dot product essentially returns a number to show you how similar two vectors are. The more similar they are, the closer to number 1 they are. And the more dissimilar they are, the closer to -1 they are, okay? And this is essentially the dot product, and if you are, of course, planning on making more games in the future, especially ones that require collisions and vector maths, then the dot product is going to be a very important function to remember and keep in mind, because it can be used for a wide range of different things. In our case, helping us calculate a reflection vector. So that is how we can reflect a vector, but we aren't done just yet, okay? There are of course many more things, such as changing the direction based on if we hit the paddle or not, as well as increasing the speed over time. So we're going to be working on that in the next lesson. So thanks for watching, and I'll see you all then.